Hi, I'm George Crump, Chief Marketing Officer at VergeIO. VergeIO has enhanced hyperconverged infrastructure. We call it ultra-converged infrastructure. Our product is VergeOS. Joining me on the LightBoard today to discuss the VergeIO architecture is Greg Campbell. He's our Chief Technology Officer. Greg, thanks for joining us today. So, Greg, what I have up on the board here is kind of a classic messy data center, right? Where we've got an Oracle environment with a SAN, a NAS, a VMware environment with a SAN. And I know one of our missions is to really simplify all this for IT. Why don't you take us through what our architecture looks like and how we would do that?
Sure, yeah. So the goal of the Verge operating system is to basically to turn all of these components into software, right? Even in a virtualized environment where we've done some hardware abstraction, it doesn't take care of everything. The data center is complicated. There's lots of components from our networking stacks, or our SAN storage, or compute, and then there's even other things that end up outside of that, from our NAS, or even environments that maybe don't play well in a hypervised, a virtualized environment, whether that be technical, performance, or even licensing issues.
Right, sure.
We give you some opportunities to still be able to pool all of that together. And the way we do that is really instead of concentrating on individual servers and virtualizing that, we virtualize the entire data center.
Okay.
So we take our bare metal x86 servers, as many as you'd like, or as few as you'd like, and we install our VergeOS on top of that.
Okay.
The operating system is going to go and catalog your hardware. It's going to look at how much RAM, your cores, if there's storage in them. It's going to look at solid states, endurance levels, spinning disk versus slow and fast, and it's going to just figure out everything as far as what to do with that.
Okay.
And it's going to present to you a pool of resources now to consume for your workloads.
Okay. And so then on here, if I'm going to put, say, solid state, but I can also mix hard drives in if I want to for longer term storage, things like that?
Absolutely. And as opposed to a standard HCI setup where everything's very alike in hardware, the VergeOS can pool and cluster those resources together into like pieces of hardware. So I still could set things up in a hyperconverged manner and have compute and storage in the same building blocks throughout and keep it simple scalability-wise, but I don't have to. I can break things up, and I can have a high-performance NVMe cluster, a spinning disk cluster, AMD cluster, Intel cluster, and it's still going to pool all that together and make it available to my workloads and to divvy up in which way I want.
Okay, great. And then from a storage perspective, we talked about the fact that we can support different types of media. What are some of the other key benefits that we bring from a storage perspective?
So the storage layer is built from scratch by us, our file system and distributed virtual SAN, and it's built in a scale-out fashion, so we can add more storage nodes as we need, all runtime, no downtime, and it's also one of the only file systems that is built natively for deduplication.
Okay.
Deduplication is not an add-on; it's not even an inline type of process. It's actually built into the file system itself. It's expected to happen. And
so the benefit of that is greater efficiency, less overhead as far as running the process and things like that?
Yeah, it's the typical things you would think of, like better performance and better efficiency. But there's also some cool things we can start to do too by having it built in. So things like when we clone environments or take snapshots, it's very, very inexpensive for it to do that. I mean, we're talking milliseconds, even if it's a petabyte of data.
Okay.
It's also globally deduplicated. So that means not only is my local system aware of this data, but as I start to replicate and synchronize with other locations, they can all be aware of the same duplication benefits across the wire.
Okay, that's great. And then you had touched on it a little bit, but we can also scale down. So for edge computing use cases, we talk a lot about being able to run on two NUCs or mini PCs, right? So that that's one of the other unique, I think, benefits of this is that you can run it at the edge. It can also master an entire enterprise data center.
Absolutely, yeah. The software's, we're not expecting the hardware or leaning on the hardware to do any of the real heavy lifting. We try to do everything in software, and what that means is we're not tied to any very specific accelerators or things that need to happen within that. So yes, we scale down just as well as we scale up, from very large high performance computing environments all the way down to a couple nooks at the edge.
Okay, perfect. So let's go back to our poor guy that's probably trying to run this data center, and let's start talking about how we bring these environments in. Now, you mentioned that the different requirements in the workload, sometimes licensing. My concern would be performance. I would think a lot of times you got that Oracle cluster sitting out there because you're worried you want consistent performance and things like that. What do we have that makes sure that when I bring that Oracle environment in, it's still going to get the performance it deserves?
Yeah, so the goal of the VergeOS software is to not get in the way to not be the bottleneck.
Okay.
It's the driving force in our development, and so we've a lot of the components within this wasn't built taking a bunch of existing products and existing pieces and trying to stitch them together and integrate them. When you do that, you create opportunities for latency, compatibility issues, security issues.
Sure.
This was built from the ground up for the purposes of this.
Okay.
So the storage is very well aware of what it's doing. It's optimized and designed specifically for creating virtual workloads. The hypervisor is talking specifically to the storage and aware. The networking fabric knows exactly what it's being used for. Everything's been built and assembled specifically for this, so we can get very, very large performance gains and kind of stay out of not be the bottleneck.
Okay. Now, I know another thing we would talk about a lot is multi-tenancy. So I assume you would want to put each one of these as we bring them into their own tenant?
Yes, and so we actually look at tenancy a little different. So
Okay.
a lot of multi-tenant environments, really a tenant is just it's more of an organizational difference. It's a group. It's
Right.
and you'll still have a common database, a common system where we kind of just group our customers or tenants together, and separate them that way. We take a very, very different approach. And again, the goal here is not just to create a virtual machine.
Right.
It's to create a virtual data center.
Right.
So now that I have this operating system running and I have this pool of resources, what I'm now going to do is I'm going to spin up not a VM, but a virtual data center. Okay. Now this virtual data center has all of the storage. It has all of the networking. It has the compute, and it's got all of our management layers. That's user management. It's got its own web server. It's got its own database server, and it's actually got its own little mini instance of our VergeOS.
Okay.
And what that has now done is it created a complete hardware abstraction layer from everything underneath here.
Okay.
So this is treated as its own independent object.
Okay.
I can now clone this, replicate it, send it to somewhere else. And where it's this little portable unit now that is verified and can send out, and it could even be picked up and moved to something that has a completely different hardware footprint, manufacturer, architecture. It doesn't know the difference
Because it's abstracted.
Yes, and it's completely isolated now from everything around it. So as I spin up that next virtual data center, they're independent, their own interfaces, their own management, user management, APIs, everything else. And the VergeOS is ensuring that everyone's, there's a proper fair queuing, no noisy neighbors, and
Okay.
from that.
So as far as then allocating resources to this, so I'm assuming that we're going to take that Oracle environment maybe and put it in here, right? Then when I do that, how do I say, okay, I got this pool of resources that you just described. Do I have to dedicate it to that environment, or are those resources still available to the other virtual data centers as well?
Great question. So the answer is you have a lot of control. You
Okay.
can do whatever you like there. So typically with public cloud and other things, the allocation of resources is more at the VM level.
Okay.
I'm going to create a VM. I'm going to assign specifically how many cores and how much RAM it has. For us, we look at more at the data center level, at the pool level. So of the cores and RAM and storage that I have here, it's as simple as when I fire this up, I'm going to say, okay, you get 32 cores, 256 gig of RAM, and 100 or a terabyte of storage, whatever the numbers are.
Right.
Within here now, this environment can do anything it wants with it.
With just those resources.
With just those resources.
Got it.
If it wants to take those cores and over provision it 4-to-1, have at it.
Okay.
It's not going to affect anything else in this environment.
Got you.
If I, as a hoster or at this level, want to dish out more cores than I have available and over provision at my level, I can do that.
Okay.
And same on the storage. The storage, it's going to automatically make sure that everyone's got a fair access to the storage. But as you provision these, you can also give certain preferences to different tiers of storage. So I could assign maybe a higher performing tier to this environment versus that one.
And then the one thing I'm pretty sure I know the answer to this, but I want to just make sure we emphasize it. When I do bring this, so if I bring Oracle into here and let's say the NAS solution into here, I'm not using their NAS service. We provide our own NAS capabilities, correct?
Yeah. So the Verge operating system, we try to kind of go up to the guest level, and then from there, that's kind of where we pull back. But anything that we see typical in a data center, we try to give to you. So every virtual data center has its own NAS capabilities.
Okay.
They all have their own user management. We even have our own LDAP type replacements, and a lot of the components that we see you should need. Full networking stacks. Every virtual data center can have as many firewalls built in, layer 2, layer 3 routing. We could do your BGP management, your authoritative DNS. Lots of the things that you would normally have separate appliances for, we just bake right into each one of these.
Gotcha. And then the other thing I wanted to make sure we highlight is that deduplication. If by chance a piece of data is in here and in this data center, even though they're two virtual data centers, it's deduplicated down here, correct?
Absolutely. So that's where some of these other additional benefits to our dedupe come into play, because the dedupe is not just giving you the benefit of consuming less data. It's also giving you the benefit of being able to manipulate these large data sets very quickly.
Right.
So now that I have this container of my entire virtual data center, which could have been everything here in one,
right,
or it could just be the Oracle or my VMware stack.
Right.
Now I can start to do some really cool things. So let's say this is 500 terabytes of data, and we just had a ransomware attack. Well, now I want to figure out when that happened, or maybe even roll it back. I could take this entire data center as it is, hit a button, less than 30 milliseconds later, that 500 terabytes is available right here and running.
Okay. So then I can do
isolated.
So then I can do my investigative work to figure out where this thing happened.
Absolutely. And it's running live. I didn't have to take this down yet. It's running in its own virtual bubble.
Right.
Same MAC addresses, same IP addresses. Everything's still interconnected. The firewall is exactly as in the state it was an hour ago. All the components of this data center come along for the ride.
Got you. And then, so then the other thing I want to make sure we understand though, so I can make that copy to diagnose, but this guy's infected. How do I get him back up and running while I'm doing my diagnosing work over there?
Yeah. So once you figure out where and when you want to come back to, it's as simple as either hitting the button to roll this back to that point in time, or make this become the new environment.
Okay, so we would leverage like snapshot technology to pull that off.
All the snapshotting is built in. We have an automated engine for managing the snapshots, cleaning them up. You just tell us your retention points, and we take care of the rest.
Perfect. All right, let's talk about the last one. So I've got this VMware environment. We've already mentioned that we have our own hypervisor and everything. How do I pull my VMware environment into this? Is it pretty easy to migrate the virtual machines in?
Very, very simple. Okay. So I'm going to spin up my next virtual data center, and inside of here we have a VMware service. And what I'm going to do is I'm going to point it over there to my vSphere. Sorry for writing. And inside that user interface, I'm just going to, all of a sudden, once I just put in my username and password to my vSphere, you're going to see a list of all your VMs that existed. Check off all the ones you want, hit import, done.
And then you could just do a quick test to make sure you're comfortable with everything, and you're up and running.
Absolutely, and it'll even do the change block tracking. So technically, you could set it up and basically be just backing up your environment, to this right here, and it's ready to hit go. Or individually pick them and play with them, test them. But
so that's interesting, though. I could do that, test everything for a while this is still in production, say, wow, it actually works like the sales guy said it would, and then do a quick update to whatever changed while I was doing my testing, and then I'm back in production. I'm fully in production.
Absolutely, yeah. In fact, that's what we do during normal imports anyways, because there's a full change block tracking mechanism. We interface with that. So you kind of usually do a one pass, get the initial data set, and then you do a refresh, and it gets whatever changed since then, and then you can pick them one by one to move in, or hit start on all of them.
Perfect. Well, Greg, thanks very much for showing us the architecture here. I think what you're seeing here is the real ability to simplify operations, which should reduce those expenses by about 70%. By the way, upfront, we typically see customers reducing expenses by about 50% just on the raw cost. So huge advantages there. If you want to learn more, go to verge.io and look at all the information on our website. For now, though, I'm George Crump, Chief Marketing Officer with VergeIO. Thanks for joining us.